Hello guys, I hope all of you are fine. In today's lecture, we will be doing the worst case time complexity analysis for QuickSort. Now, many of the company officials can ask you this question that what according to you, if you have to compare merge sort and QuickSort, which is the best algorithm, it is dependent upon problem to problem. Let's say one problem which is given to us is that we have been given 5 elements which are sorted elements 10, 20, 30, 40, 50. Now, if I have to basically compare which algorithm is a better algorithm, we have to analyze every algorithm on its worst case time complexity analysis. So, this is one of the worst case time complexity analysis of QuickSort. 10, 20, 30, 40 and 50. Now, how do we start? Again, we have a starting element which is 10 and we have an ending element which is 50. Now, we always say that start is greater than equal to 10, return 1, but we are going to have a P index which is partition index from the partition function a start and end. The moment it starts, so we always give initial part as your partition index. Now, let's start this whole scenario. If I start this whole scenario, we go to partition function. In that, we are basically going to compare your if this is my ith initial start element, and we are going to compare it with the pivot element. We are taking 50 as a pivot element. 10 is compared with 50, obviously it is lesser than 50. So, we are going to when one element is lesser than the pivot element, what we do, we update the index, we put the index over here and partition index comes over here, right. Then again 20 is compared, again partition index comes over here. 30 is compared with 50, again partition index comes over here. 40 is also less than 50. Now, what we have to do in this particular scenario, your partition index comes over here. So, this is your PI, right. Now, what you have to do, you have to basically separate your start element with P index minus 1, means if this is my partition index, since this was the element that we wanted to basically compare our initial 4 elements with, everything was lesser than 50. So, your partition index comes over here. When partition index comes over here, you will use this statement. You have a start, which is this element. It works from start to P index minus 1. Now, guys, your start element is 10 and it works 10, 20, 30, 40 and 50. So, it means it will work till P index minus 1. It means it will work from 10 to 40, right. So, this is your partition index. Your partition index comes here. So, it is working from, again it is asking it to be solved. So, again QuickSort will be called from 10 to 40. Then again your partition index will come over here. This statement and this statement you have to analyze. So, this statement again 40 comes here, then again 30 partition index will come over here, again partition index will come over here, again partition index will come over here. So, eventually you are sorting the elements. First sort gave you first iteration gave you 10, 30, 40 and 50. This was your partition index, right. If I will solve this whole scenario, it will give me 10, 20, 30 and this is your partition index. Then in the next step, if I solve, it would be giving me 10, 20, 30 and then 40, 50. Then this would be a partition index, and in the last it will give partition index as I when we sort all the elements. Now, you need to think about this pretty clearly, that if this whole scenario, is it giving you any partition? Is this whole scenario giving you any partition? Because in the very first iteration you had your partition index as 10, 20, 30 and 40. This was your partition index. So eventually you are having your partition like this. Then after that you will have partition index over here. So actually the problem is not getting divided. Why? Because you are just reducing the iterations altogether. So earlier it was running till 50, then it was running till 40, then again it is running till 30, 20 and 10. So the problem is actually getting reduced, not partitioned. So partition, if I am writing this code, that p index is giving us a start, we were having the function partition and it was giving array start and end. This is definitely going to run for n times, right? This is definitely going to run for n times. Now comes with this part, your QuickSort and a start p index minus 1. This statement, since this statement actually did not get divided, we have elements such as 10, 20, 30, 40 on one side and 50 element on another side. I am talking about the very first iteration. So this was the partition that was done. This was the partition. It means how many elements these are? These are total 5 elements. Now these were n minus 1 elements and this was only 1 element. So it means if this process is getting, this is getting reduced, not partitioned, eventually if I have to execute this particular statement, this will run n minus 1 times. Then again if I divide this, if I basically try to divide, I would get like this. I will have the problems with 10, 30, then 40 would be another particular part. So it means this is something which is getting reduced. Hence the time taken by a partition function, it is definitely n, but the other parts, QuickSort, a p index plus 1 and end, this is running for t of n minus 1 times. Why? Because 10, 20, 30, 40, they were on one side and 50 was on another side. So it wasn't getting divided. So it is having the elements of 10, 20, 30, 40 and then we have to work for 10 to 40. Then we work for 10 to 30, 10 to 20 and eventually 10. So it means your entire time complexity is dependent upon n, which is the number of elements, and t of n minus 1. These are separate statements altogether. And what about this statement? Since your partition is the last element is a p index, so p index plus 1 won't be existing. So this is not going to run accordingly, right? Even if you try for this was your partition index, what will be p index plus 1? There will be no value. So eventually this is your time complexity. T of n is equal to t of n minus 1 plus n. N is for the partition function and this is actually for whatever initial dividing function you have written. So this was a dividing function which turned to be a decreasing function. And if I basically try to analyze the complexity of this particular code, it would be t of n is equal to t of n minus 1 plus n. I can easily calculate this thing. I can replace by substitution method. I will get t of n minus 2 plus n minus 1. So this is t of n minus 1. If I write t of n, it would be t of n minus 2 plus n minus 1 plus n. If you see, this is 2, this is 1, this is 0. If this is running till k times, it would be t of n minus k. It could be written as n minus, this is if this is k k minus 1, this is n minus k minus 2. If this is n minus 1, this is n minus 0, this is n minus 2. So, if this is k minus 1, this is k minus 2. If I stop this entire scenario, I would write n minus k is equal to 0. Eventually, your k value becomes equal to n. So, I suppose if this is running till k times, I see that t of 0 I can easily write it, and more importantly, your k value is n minus 1, it would be 1. So, this is running till n minus k minus n. So, eventually this complexity would be 1 plus 2 till n particular parts, right. So, eventually this would be n minus k will be cancelled, plus n would be there. So, it is n plus 1 by 2 divided by 2. So, theta n would be order of n square. Guys, we have already discussed the master's theorem of this. Even this will give you theta of n square, that is the worst case time complexity of QuickSort. So, important takeaway from this, last, it wasn't divided. So, p index was the last element, p index plus 1, this would not work. So, this was the important point, and here the problem is actually getting reduced. You see, from 10, 20, 30, 40, 50 was this. So, this was reserved, and then we have to work for 10, 20, 30, 40. Then we work for 10, 20, 30, then 10, 20, then 10. Eventually, it is getting decreased, not divided. So, if you like this video, kindly like, share, subscribe. The worst case time complexity of QuickSort is actually n square. Kindly post comment section if there is any kind of doubt. Thank you very much.